What's up, guys? Last time we made a tic-tac-toe game. We can play it all the way through until somebody wins, but that was just me playing both sides, and I don't really want to do that. I don't want to get another human in here either to reach and touch the same keyboard. I'd rather have a single player mode where I can make a move than the computer does, make a move than the computer does. Interactive, just like most games should be. So the good news is almost all the code gets to stay the same. Everything on screen right now, still just fine. Everything on screen down here, yep. Maybe the main function is the only thing that'll change, or maybe we'll add another function somewhere else. So basically right here is the thing we have to worry about. If I'm getting the input every turn, well, we want to change it so that I'm getting the input on half the turns, and then getting a computer move through some other path the other half. For example, let's just say that human is X and computer is O. We can add a step later where maybe at the beginning of the game it asks what you want to be, or it flips a coin, or it decides, who goes first, something like that. But for now, we'll keep it simple. Let's just say if we're X, we do the same thing we were already doing. We know that works because we've been testing it quite a bit. And if we're O, that'll be the computer and they'll do something else. Okay? Tic-tac-toe is not that complicated, and it is possible to make a perfect strategy where it looks at all the possibilities, like Dr. Strange looking at all the possible futures and picking the one where you win. But since tic-tac-toe is a small game, there aren't that many possibilities. However, for now we're going to do something much simpler. We're just going to do random. We'll just have it pick a random move and then go back to the human. So in order to do that, you might have seen we've used random a few times recently, like the card game, we would shuffle the deck, or when we did Hangman, you could pick a random word from the word bank to get started. We have to import random right at the top. Now that's built into Python. It's not something you have to download from another guy who made it on his own. Random is part of the language. It's what they call the standard library. So most languages have a standard library to handle common things like math, networking, saving different types of files, and random is another one. So if we import random, then we get all of these functions that we can use. And I think I'm going to start with a function called choice, which does what you think it does. It just picks one from a sequence of things. So if I go random.choice, and then I give it, these are like the possible inputs, right? Each one character of these. And then if I run that, it'll get us going, right? Just that one line is enough to say, okay, if I pick 1, hey, the computer picked 2. If I say 5, hey, the computer picked 8. But the issue is there's no safeguard, so they might pick one that's already taken. If I do, did you see that? I had 5 in the middle, and they picked 5 randomly to make themselves win by cheating. You can't do that. In tic-tac-toe, if a spot is already occupied, you can't change it. And the reason why that happened is because we just pick a random word and then move on, or a random character and then move on. So I could add this validation step, just like I did with the human, and obviously there are other ways to do it, but it's nice to just reuse stuff we already have. So let's do that. Let's say, while it's not valid, we just do it again. So this means that it goes through exactly the same process as the human did. So if I say 11, well, it's not going to let me. And if I say 1, if I say 1 again, it's not going to let me because that spot is occupied. It's just not one of the available choices anymore. So, of course, we could handle this differently. We could have the random look at the board and then see what's available and then only choose from what's available. Or we could have it do the row and column separately instead of treating it like a single character string. But the benefit of this is that it's going through all the same processes that the human input did. So we can validate it the same way. We can do this unfold the same way where it turns into the row and column. And great, what did we add? 4 lines, 5 lines? Just to make an entirely new mode. We have this single player experience where I can go against a computer, and it'll even win some of the time, right? It's not very smart, it's just random. But if I try to lose, let's say, it's probably not going to win this round, but let's say, okay, if it does 3, if it does the top right, it'll win. So if I pick some other parts, I can avoid that. Or if it does 8 in the bottom, it'll win. So if I say 6, for example, well then it has no choice but to win. All of the available slots that it had would have been a win. So even a random opponent is going to win every once in a while, but that's not very interesting because if I'm walking up to this and I don't know the code, I might assume it's doing okay, but after a few rounds I'll realize, oh, this is really bad. It's not even trying to win. If you notice, this doesn't know what the board is. It doesn't know that it's O rather than X. It doesn't know anything. It's just picking a random character. So if we add a better strategy later, we'll let it know what the board is and say, hey, here's the situation and you're O. What can you do with that? And we can give it some simple strategies, like if you have a win, take it. Like if I have O blank and I can go ahead and take that blank, we can do that. Maybe if the human is 1 step away and we can block them, maybe we take that. Or we could go further, like I said, and just actually check every possibility. There's a classic algorithm called minimax where you have it look for the path. So like, what if I did this and then this and then this? And it'll have this branching tree, and at the end of a tree you'll give it a rank. Usually win is just like +10 or some positive number, and lose is -10 or some negative number. But you could also add another layer and have it give the shorter ones a better rank. So if I can win in 3 moves, that's even better than winning in 5, you know. So we could get into that, but as a start, this is great. We have a whole new mode just for a few lines of code. We didn't have to make any new functions because we were just using the strategy that was already there for the humans. Great.